Hello and welcome to another episode of AWS Cloud Bytes. I'm your host Bhavesh Kumar. Today we are having a new series around cloud architecture patterns and workflows. And the first one in the series is about CQRS on AWS. We're going to see a pattern where we'll have Lambda DynamoDB streams, and OpenSearch. So let's begin. What are you going to learn in this? You're going to know what exactly CQRS is and why do we need in certain scenarios, how to implement CQRS using AWS and common AWS serverless components, how does the write model and read model stay in sync, and we'll talk about eventual consistency. We'll also look into the failures, retries, idempotency, monitoring, and security aspects of it. Let's talk about the problem CQRS solves. Usually in legacy systems or a lot of databases that I've worked, I've seen that writes and reads operation, they were done on a single database schema, which means the writes over a period of time, they get complex due to evolving schema, having search, filtering, aggregations, and different kind of read requirements where you were merging data, joining data from a lot of tables. In such scenarios, CQRS comes to our rescue. CQRS is a pattern. The full form of CQRS is Command Query Responsibility Segregation. It's a design pattern that segregates data writing, which is commands, from data reading, which is queries, into distinct models and data stores. When the data is written through CQRS pattern where the command is executed, it takes some time, so it's eventual consistent across the schemas. So when you write in schema 1 where the commands are triggering a write operation, that information flows from schema 1 to schema 2 from where the reads are happening. So let's look into additional details of CQRS. So this section, CQRS in one sentence, is showing how the AWS version is going to work. We'll have an API gateway that will trigger a Lambda for the write path, and which is going to persist or update information in DynamoDB, while the read path is using the DynamoDB stream, where the stream is persisted in an OpenSearch and you read from the OpenSearch indexes. Let's look into this particular diagram. The user from the front end makes a call, API gateway receives this information. The request comes in as a command, which means all post, put, delete. They will go through this command handler, and this command handler is going to write it to the DynamoDB database. As soon as the data is written in DynamoDB database, the information is then channelized through the streams, which is the CDC, change data capture kind of events. So the events are raised, and you'll have messages in the DynamoDB stream. Then there will be a processor that is going to process the DynamoDB stream messages, and it is going to persist this information, add, update, insert documents in OpenSearch, which is our read database schema. Now, in case of failure, you can always go to a DLQ, which is a different path altogether. You can reprocess the DLQ. So that's a failure condition. We are not going to talk about the failure. Once the insert or update or delete, whatever was the HTTP verb that it came with, the document has been updated in OpenSearch, given the old and the new image that is being sent by the DynamoDB stream. Now, if a request comes in to fetch certain object, searches, filtering, any kind of querying that is happening, it goes directly to the query handler, doesn't go to the command handler. Now the query handler talks to OpenSearch. Over here, then OpenSearch provides the response, and then this response is sent back to the Amazon API gateway. From there, it reaches the user or the front end. These are two optional things that I'm showing. We're not going to cover up CloudWatch or X-Ray. These are more of how the logs are maintained, what kind of metrics and alarms you can configure. The CloudWatch and X-Ray, AWS X-Ray, they are shown over here just to show the observability aspect of AWS architecture in this. CQRS pattern. Let's go through each and every component. So API gateway, as I already mentioned, it's a HTTP endpoint, or you can have a RESTful endpoint, and you can have a rate limiting, authorization, authentication, and kind of a request validation that can be performed over here. The command Lambda is going to validate the command. So you say, I want to insert, update, or delete. So given the command that you have for those HTTP verbs, it is going to write the data to the source of truth. In this case, DynamoDB is the source of truth because it is where you update the information, and then the information flows to the read schema. We are just reading from the OpenSearch. DynamoDB, it's source of truth, and it is optimized for writes and correctness rules. Then the stream is basically anytime there is a change, you receive information in the stream so that you can sync that information to the other schema that you have, which is OpenSearch. The project Lambda is basically transforms any kind of information that came out of DynamoDB, reads that info and changes to whatever is required for read capabilities. So the read schema may be different, and the stream projector can pull in this information from DynamoDB, and it can then translate this information to whatever schema OpenSearch is expecting so that it can serve the search or filtering requirements from the query handler. OpenSearch is a schema that we are going to use to provide capabilities such as searching, filtering, sorting, aggregation, and paging, depending upon how many indexes, what kind of indexes you're building, what kind of mapping you are doing for those, what kind of tokenization you're doing for those kind of indexes. So you can have a full search capability, you can have a partial match, you can have some kind of type ahead feature if you want using those. Now, going to the query Lambda, it is just querying Lambda, which is going to take the inputs from the UI, coming through the request, and then this querying handler is going to just optimize that to a query that OpenSearch understands. OpenSearch will be running at port 9200 or whatever port you will run it if you have a custom port. And then using the HTTP request, you will receive the response from the OpenSearch. Now, as I already mentioned, DLQ and CloudWatch X-Ray, they are more for retry logic, alarms, notifications, any kind of logging info. Let's look into a concrete example from an order domain. Imagine this is an e-commerce service. So what kind of commands you can receive? The commands can be create an order, confirm a payment, cancel an order, ship an order. Those kind of commands can come. This is more about how these commands are going to conform to business rules, such as don't confirm payment twice, don't cancel a shipped order, validate inventory. These are more of business rules that you're going to apply. But the idea is when a create order happens, how are you going to persist that information, and how are you going to share this information to the user saying the order has been created? Now, queries are something like I want to understand what has been stored, or I want to search about some info. And you can say, show me all the orders for a customer, or customer can say, I want to see my orders, or search my order for a given product name in my orders. And then these can be internal facing or external facing. Internals, you can say, give me daily revenue totals. But for a customer facing, it can be like, I want to see my order. Is it shipped or not? Let's run through a sequence diagram in this. Now, this is the command user posts an order. So it goes to an order command. API gateway invokes after it is authenticated, validated. So authorization authentication is done. The command, which is the Lambda processing the order command that came in, will validate the request and also apply the business rules, and then perform operation like put item or update item or create item, those kind of operations, and then we'll receive a 200. Now, once you receive 201 or something, or in this case, we are showing 202 accepted, you'll send the order ID and the status information back. But this status may be just saying created, not saying that order is in progress or something, or maybe order is shipped or something. This is just initial status. Now, as soon as the write operation happens, the response is received and a stream will receive information saying the object has been created, modified, or removed. Let's go to the read side of it. As of now, the stream has the information. Once DynamoDB creates an object on the stream saying it was created, updated, or deleted, then until it is processed and persisted in OpenSearch, if you perform a read operation in this duration, you will not find the order because we are reading from OpenSearch directly. So this is our read model. Now, what happens is behind the scene, Lambda is listening to the stream and it processes the stream, processes the message, inserts or updates the document in the index and gives you a success. In case of a failure, it will perform a retry using the DLQ. You can perform a retry further. Now, once the information is persisted in the index and user says, get me information about the order where the customer ID is this, the query lambda is invoked. Now, query lambda is going to send all this information to the OpenSearch, and OpenSearch will give you the response. And user can then see the list of orders on the front end. The caveat to this is like if you are still processing at this point and the user makes a request, you will not see any response. The order that you just placed will be missing. And that is why it is called eventually consistent or eventual consistency. Because the information is not persisted in both DynamoDB and OpenSearch in a single commit. It is eventually consistent in both the databases. Okay, let's look into why DynamoDB and DynamoDB Stream plus OpenSearch is a common CQRS combo in AWS. DynamoDB is very good for high throughput writes, conditional updates, and it's very good at scaling. Now, Streams gives you a durable way of getting the information what was before, what is after. So you get a object where you can say the stream can send me just a new image, or you can say send me the previous image and the new image both as part of the stream object. So a stream can be used to sync multiple schemas like DynamoDB and OpenSearch. They are getting synced using the stream. And this is a change data capture capability, very similar to what you have in almost all modern databases. Now, OpenSearch, you create an index that allows you to do searches, filters, and you can have facets created. You can have your full text search, you can have aggregations, all those sort of things can be done easily using OpenSearch. So this is something that helps you building complex queries, getting rid of a lot of joins. You can have index built based on the capability, search capability that you want to introduce. You can have multiple search indexes, each one of them tweaked towards the searching capability that you want. Let's talk about some production checklist. And this is to make sure that your CQRS works reliably. So idempotency on the projector, basically stream can deliver and there may be a retries. So the stream processor, if it is performing update operation, it should be safe to repeat. And error handling with DLQ and replay strategy. So you can have SQS queues in case there is a failure to process the stream message so that you can replay that message and persist. So that will allow, at least in case of failures, you can handle that and reprocess the message that was introduced. Ordering and concurrency assumption. When the stream receives the messages, it is usually ordered, but it is possible that it can be out of order, and then you can have out of order updates. So if you need things to be in a certain order, you need to design for things like messages are out of order, and if you're doing concurrent processing, how you want to handle that. The next one is data modeling, the OpenSearch document. You can have multiple indexes, each one specialized to a search requirement, a filtering requirement, grouping, aggregation, any kind of sorting, pagination. All those sort of things are easily affordable when you go through OpenSearch. You can have different kind of mappings. Your mappers can define what kind of tokens you generate and what kind of search capabilities that will introduce as per your searching needs. So OpenSearch documents should be built in a way that it is highly denormalized so that you can have best of your query performance. Observability, it's a minimum requirement that you have CloudWatch alarms and any kind of DLQ, or OpenSearch write failures, all that should be notified. And then you can have a dashboard where you can see how many objects are pending in the stream, like what is the age, what is the lag. So these two things will be helpful for production. Security, you should always follow the good defaults that we have, which is least privilege should be given based on Lambda is getting data from DynamoDB, then only access should be DynamoDB stream. Similarly, if it is writing to OpenSearch, the only thing it can perform is the operations it is allowed to do on OpenSearch. You should also have encryption enabled on DynamoDB and the OpenSearch. This is for data at rest. Then, if the OpenSearch is in VPC mode only, which means you're running OpenSearch as part of one of your subnet, and your Lambda will have to be as part of your VPC so that you don't have to build any kind of networking, additional networking, in case your Lambda needs access to connect to DynamoDB as well as your OpenSearch. Cognitive and all this is more about auth. I'm not going to talk about it because it is more about how your API gateway can handle those authorization and authentication, which is not the topic of this particular architecture. Now, where does CQRS fits in and where it is an overkill? It is great when you have a read pattern that is complex and changes frequently, which means you can change your read models frequently without touching your write models, and you can keep persisting your write data while your reads can be done from different kind of read models and that can evolve over a period of time. Your search and analytics capabilities can change and it should not be impacting your writes, and then you are okay with eventual consistency, which means you don't need a ACID compliant database in a way that you want to read after immediate write. Now, where it is an overkill, basically, if the read and write operations are not such significant, and if it is a small application, you can start with a single database model. Your domain restricts read after write consistency everywhere. Then in that case, it will be difficult because CQRS will give you eventual consistency. And you have a very small team, and your operational capability is the simplicity that is what you're looking for, then in those cases, it's easier to maintain a single database model application rather than having a CQRS kind of a complexity. There are some optional upgrades that you can look into, but these are primarily all focused on how AWS can do things. Like we can have a stream projector with replace it with Event Bridge or Kinesis, and then you can have a more fan out model. You can also use Aurora RDS, and you can also have step functions for multi-step workflows. So you can evolve the complexity as in what is required, but this was the simplest possible architecture that I was sharing. You can also split your microservice And this is a good way to do is like you can have your read services, then you can have your write services, where your read services can be scaled independently if your read operations are increasing, or your write services can be scaled independently if your write operations are increasing. So you can split them in this way rather than having one single service that performs read and write, both the command and query operations. Anyways, that is the end of this particular discussion. Hope you like it. Let me know. Please like, share, subscribe, and press the notification bell icon for future updates. I'm your host Bhavesh Kumar signing off. Thank you.